Alright, today's lesson is 6-2, solving systems by substitution. Our objectives are to solve linear equations in two variables by substitution and to solve contextual problems and interpret the solution. We're going to do that second objective in class tomorrow. Alright, this is your first example. Go ahead and write this down just the way it looks for me. Number 1, the top one is y equals 3x, and the bottom one is y equals x minus 2.
Make sure they know that's a bracket.
Okay, and this part right here is just a bracket showing that these are a system meaning two equations. Alright, hopefully you've got that written down. If not, you can pause the video if you need to. Our first step when solving by substitution is to write these two problems side by side. So I'm going to write this one first, y equals 3x, and then over here I'm going to say y equals x minus 2. So our first step each and every time with substitution is to write them side by side. Then we're going to look for a variable that's solved for, meaning that it's x equals or y equals, that's by itself. So here our y is by itself here and here, so we can pick either one of these. I'm going to pick this one, and I'm going to put a box around what's on the other side. So I'm going to put a box around that 3x because y equals 3x. So it's y that's solved for, so I'm going to look for the y in the other equation, and I found it right here. So I'm going to draw an arrow from my box to that y. And instead of y, I'm going to substitute in 3x, or replace y with 3x. So instead of y, I put in 3x. And now we're just going to solve for x just like we would if it was any other equation. I'm going to go ahead and put a 1 in front of this x right here, just so that I know that that's a 1. I have x's on both sides, so I'm going to subtract 1x from both sides. And I get 2x equals negative 2. Don't forget to bring that down as a negative because it's minus 2. Then to get rid of the 2, I'm going to divide both sides by 2. And x equals negative 1. Alright, so I've solved for x. Now when we're solving systems, we have to solve for x and y. And we're going to write that as an ordered pair, just like we did whenever we graphed them and found that point where they met or crossed. We're finding that same answer here, just a different way of finding it. So now I'm going to take the x equals negative 1, and I'm going to plug negative 1 back into this top equation for x, because I know that x is negative 1, so instead of x, I can plug in a negative 1. So we're going to say y equals 3 times negative 1. I just replaced the x with the negative 1. 3 times negative 1 is negative 3, so y equals negative 3. Now that I've solved for x, x is negative 1, and now that I've solved for y, which is negative 3, I'm going to write that answer as an ordered pair with the x first, so negative 1, comma negative 3. And that's my xy ordered pair. So if I were to graph these two, they would meet or cross at the point negative 1, negative 3. Now since we have that answer, we've got to check it to make sure. So we're going to check the point negative 1, negative 3. And we have to check it in both equations. So I'm going to go back to both of my originals. And everywhere I see an x, I'm going to plug in a negative 1, and everywhere I see a y, I'm going to plug in a negative 3 and make sure that it works. So I'm going to say y equals 3x, and instead of y, I'm going to put in a negative 3. And instead of x, I'm going to plug in a negative 1. 3 times negative 1 is negative 3, so that checks out. Negative 3 equals negative 3. Now I'm going to check it with the other one. Y equals x minus 2. And instead of y, I'm going to plug in my negative 3. Instead of x, I'm going to plug in my negative 1. On this side, I just have the negative 3. And on this side, negative 1 minus 2 is negative 3. So negative 3 equals negative 3, and that checks out as well. So this is my solution to my system. This point right here. Make sure you have all of the work and the check written down for that problem before you move on.
Pause the video now if you need to.
Alright, go ahead and write down number 2. Again, this is just a bracket showing that these two equations are together in a system of equations. We have on the top we have x equals 5y, and on the bottom we have 7y equals 2x minus 1. Again, our first step is to write these side by side, so I'm going to say x equals 5y, and on this side 7y equals 2x minus 1. All right, again, we're going to look and see, okay, which one of these has a variable that's solved for here. So we're looking for an x equals or a y equals. And we find that right here. The x right here is by itself, so it's solved for. So that's what I was looking for, is I was looking for x or y by itself on one side of these, and this x is by itself. So I'm going to put a box around what's on the other side of that x. So x equals 5y, meaning that x and 5y are the same thing. So here, since it's my x that's being solved for, I'm going to find the x in this other equation over here, and I find it right here. So I'm going to draw an arrow from my box to that x to show that I'm going to substitute in 5y for x, or replace it. So I'm going to say 7y equals 2 times 5y minus 1. I went ahead and put parentheses around that because it's saying 2 times x, so I want to say 2 times 5y. And now we're just going to solve for y. We're just going to figure out what y is equal to. So we're going to say 2 times 5y is 10y. I have y's on both sides, so I'm going to subtract the 10y from the 7y. I'm going to say 7 minus 10 is negative 3y. And then I need to get the y by itself, so I'm going to divide both sides by negative 3. And y equals negative divided by negative is a positive, and I'm going to leave this as 1 over 3 because that's a repeating decimal. If it's a nice pretty decimal, then you can leave it as a decimal. If not, you need to leave it as a fraction. So I found my y equals 1/3. Now I have to go back and find the x because I'm looking for the x and the y. So I'm going to take the 1/3 that I found that y is equal to, and I'm going to plug it back in up here for y. So I'm going to say x equals 5 times 1/3. And if you want to, we can plug that in the calculator, and we get 5 over 3. And again, we're just going to leave that as 5 over 3. So we found our x and we found our y. So we're going to put that into our parentheses. So we're going to say our x first, so 5 over 3, comma our y, which is 1 over 3. So that's 5 over 3, comma 1 over 3. So that's our solution. Now that we've found that solution, again, we need to check to make sure that we were correct and didn't make any mistakes. So over here, we're going to check that. This is my x and this is my y. We have to again check it in both. First one I'm going to check it in is x equals 5y. And instead of x, I'm going to put in 5 over 3. Instead of y, I'm going to put in 1 over 3. I'm going to plug that into my calculator, and I get 5 over 3 equals 5 over 3, and that checks out. Then I have to check it in the second one, so I'm going to say 7y equals 2x minus 1. Instead of y, I'm going to put in 1/3. Instead of x, I'm going to put in 5 over 3. And again, if I were you, I would use that alpha y equals button on my calculator when you're working on these in class tomorrow to check these. I definitely would not do this by hand. And when I plug this in my calculator, I get 7 over 3 equals 7 over 3, which checks out. So both of those check. So this is my solution to my system. Okay. Which means if I were to graph these, it would cross at 5 over 3 and 1/3, which is the other reason that we don't always just graph. We have to use substitution here, because if I were to graph this, I wouldn't know exactly what point in which they were crossing. And if I use substitution, I can find those fractions. Make sure you have all of the work and the check written down before you move on. All right, go ahead and write down number 3. Again, you have your braces here showing that this is your system of equations. You have x minus y equals 5, and then you have x equals negative 2y minus 1. So again, our first step here is to write these side by side. So I'm going to say x minus y equals 5, and x equals negative 2y minus 1. Again, my next step is to figure out, do either one of these have a variable that's already solved for, or have a variable that's by itself? And this one does. This x right here is by itself. It's x equals. So this is what I'm looking for. I'm looking for one of them that has the variable by itself. So I'm going to put a box around the other side of this one this time. And since it's x that's solved for, I'm going to find the x in this equation over here, and I'm going to draw an arrow from my box to the x to show that that's what I'm substituting in for. Instead of x, I'm plugging in negative 2y minus 1, the entire thing, because x isn't just equal to negative 2y, it's equal to negative 2y minus 1. So instead of x here, I'm going to say negative 2y minus 1 for my x, so that I'm going to say minus, and I'm going to go ahead and put a 1 in front of that y right there, equals 5. And I'm going to solve for y. Here, my y's are on the same side of that equal sign, so I'm just going to put those together and combine those. I'm not going to do the opposite because they're on the same side. I'm just going to say negative 2y minus 1y is negative 3y. And I'm going to mark those out, showing that I combined those together. I'm going to bring down my minus 1 equals 5. Then I'm going to add my 1 to both sides here. 5 plus 1 is 6. Bring down my negative 3y and my equal sign. Now I need to move the negative 3, so I'm going to divide both sides by negative 3. And y equals negative 2. So I found my y. I can't stop there. Now I have to go back and find my x. So since y is negative 2, I'm going to go back up to this equation, and instead of y, I'm going to plug in a negative 2. So I'm going to say x equals negative 2 times negative 2 minus 1. So instead of y, I put in negative 2. Negative 2 times negative 2 is 4. 4 minus 1 is 3. So x is 3 and y is negative 2. So again, we're going to write that in our parentheses, and we're going to say that that's 3, negative 2. Again, x comes first, then the y, because it's my xy ordered pair. Showing that if I were to graph these, that they're going to meet or cross at the point 3, negative 2. All right, now I think that's my answer. I need to make sure I didn't make any mistakes, so we're going to go up here and check. Again, I go ahead and just make sure I put my x and y on the top there. It'll just keep me from plugging the numbers in the wrong places. My first one is x minus y equals 5. Again, I always go back to the originals. So I'm going to say 3 minus, now be careful here, it's 3 minus negative 2 equals 5. Anytime you have two negatives side by side like that, they turn into a positive. 3 plus 2 is 5, and 5 equals 5. Checks out. Now we're going to check the other one. It's x equals negative 2y minus 1. And instead of x, I'm going to plug in a 3. And instead of y, I'm going to plug in a negative 2. So here, negative 2 times negative 2 is 4. 4 minus 1 is 3, so that checks out as well. Make sure you have all of the work and the check written before you move on.
All right, for number 4, our two equations are 2x plus y equals negative 4 and x equals
negative y minus 7. So get both of those written down before we look at how we're going to substitute in. If you look at our second equation here, we have x equals negative y minus 7. So our x is solved for here, and we're going to plug this in. We're going to write our equations out side by side. 2x plus y equals negative 4. X equals negative y minus 7. So we're going to take this, where our x is solved for, draw a box around it, and we're going to plug this in for x here in the other equation. So when we write this out, we have 2, and then instead of x, we're going to plug in all of that information. So open parentheses, negative, I'm going to go ahead and put a 1 here, negative 1y, minus 7, close parentheses, equals, oh, I'm sorry, plus y equals negative 4. So again, all I did was plug in for this x right here. Everything else stayed the same in the original problem. So that gives me 2, open parentheses, negative 1y minus 7 plus y equals negative 4. So the next thing I have to do here is distribute. So I'm going to distribute my 2 to everything inside the parentheses. 2 times negative 1 gives me negative 2y. 2 times negative 7 gives me negative 17 plus 1y equals negative 4. So now I'm just combining like terms. I have negative 2y and positive 1y. Negative 2 plus 1 gives me negative 1y minus 17 equals negative 4. And now I'm going to add 17 on both sides. Oh, I'm so sorry. I did that wrong. Completely. Because, okay, I made a mistake, and you probably noticed it when I did it. I'm sorry, I wasn't paying attention. 2 times negative 7 is negative 14. So go back and change, because you're using a pencil and you have an eraser, it shouldn't be a problem for you. Go back and change those 17s to 14s in case you haven't already caught my mistake there, but you probably did when I did it. I'm sorry about that. I didn't mean to confuse you. So what I have here, I'm sorry, again, is negative 1y minus 14 equals negative 4. And then I'm going to add 14 on both sides. So negative 4 plus 14 gives me 10. And then I have my negative 1y over here. So now I have to divide both sides by negative 1 to solve for y. And I'm going to get y equals 10. So that gives me y equals 10. So now that I've solved for y, I've got to go back and plug that in and solve for x. So I'm going to take this, y equals 10, and plug it in up here for my y. And I'm going to have x equals, and again there's a negative there in front of that, so it's going to be the same thing as saying negative 1y, so I'm going to say negative 1 times 10. Negative 10 because it's, oh, geez, I'm sorry. Negative 1 divided by, 10 divided by negative 1 is negative 10. So I'm coming back and plugging in a negative 10 here. I'm just going to redo this one, and then I'm going to delete it out of the video. Because this is all right, number 4. Go ahead and write down your system. You have 2x plus y equals negative 4, and x equals negative y minus 7. So the first thing you're going to do after you write down this system is you're going to write the two problems side by side. 2x plus y equals negative 4, and x equals negative y minus 7. I'm going to go ahead and put a 1 here in front of my y because anytime I have a negative in a variable, I like to go ahead and put that 1 there because it just makes things more clear when I start working stuff out. I'm going to go ahead and put a box around this because my x is solved for, and this is what I'm going to take and plug in to the other equation for x. So I'm going to plug that in right here for x. What that gives me is 2 open parentheses negative 1y minus 7 close parentheses, so that's what I plugged in for x, and then I'm going to say plus y equals negative 4. My next step is to distribute my 2 to everything inside the parentheses, so I'm going to draw my arrows because I always draw my arrows when I distribute. 2 times negative 1 is negative 2y. 2 times negative 1y gives me negative 2y. 2 times negative 7 gives me negative 14 plus, because I'm going to add and subtract here in a minute, I'm going to go ahead and put my understood 1 in front of my variable here because there's always an understood 1 in front of it when there's nothing else there. Then I'm going to bring down my negative 4 over here. Now I'm going to combine like terms. I have negative 2y and 1y. Negative 2 plus 1 gives me negative 1y. I'm going to bring down my minus 14 and my negative 4 on the other side. So now I'm going to add 14 to both sides because I have to do the opposite to move my 14 to get my y by itself. So I'm going to add 14 to both sides, and it's going to cancel here, and over here it's going to give me 10. So negative 1y equals 10. I have to get my y by itself. It still has a negative 1 with it, so I have to divide both sides by negative 1. And that's going to give me y equals negative 10. So y equals negative 10 is what I'm going to bring up and plug into this equation to find out what x equals. So I'm going to say x equals, now again, there's a negative 1 here in front of the y, so negative 1, and then for the y I'm plugging in my negative 10, so negative 1 times negative 10 minus 7. Negative 1 times negative 10 gives me positive 10 minus 7, so x equals 10 minus 7, x equals 3. So now I'm going to take my answer here and write it as an ordered pair. My x comes first, the 3 comes first, and then the negative 10. Now I'm going to check this. Make sure that you have all that down before you move on because I'm out of space and I'm going to have to check on another page. Well, I could cram it all in there, but sorry, I lied. I'm going to go ahead and do it all on the same page because I need the original problem to look off of, and I want you to do yours on the same page. All right, so I'm going to plug into the original equation 2, then my x is 3, plus my y is negative 10 equals negative 4. 2 times 3 gives me 6, minus 10 gives me negative 4, equals negative 4, equals negative 4. So that one checks out. And then my other one, x, I'm going to plug in a 3 for x, equals negative 10 minus 7. Negative makes it positive, so that means 3 equals 10 minus 7, and 10 minus 7 equals 3. So that does check out to be 3 equals 3. Sorry, I had to cram that in there. Make sure that you have all the work and the check written down before you move on. All right, for number 5, you're going to write x plus y equals 3 and y equals 4 minus x. The first thing we're going to do is write our 2 equations side by side. X plus y equals 3 and y equals 4 minus x. Here I have my y that is solved for, so I'm going to draw a box around what y equals, and then I'm going to come over here and I'm going to plug it in to this equation for y. It's going to give me x plus, and then I'm plugging in for y here, 4 minus x equals 3. So now I have to solve I did it again. All right, so now I have to solve, and if you look here, you have your x's you have to combine. So you have a positive 1x and a negative 1x, and you might notice here that 1 minus 1 equals 0. These actually end up canceling out, and what you're left with is 4 equals 3. This is not a true statement. This is false. So our answer here is going to be no solution. So you notice again, when your x's cancel and you're left with an untrue statement like 4 equals 3, that is false and there is no solution. And what that means is that if we were to graph these two lines, they're never going to cross. The lines are actually parallel because they never cross, and we know that parallel lines are never going to cross. So that means that there's no solution. Now we're going to look at an example of what it means if these two ended up being equal. You don't have to check this because there's no solution. No matter what you plug in, it's never going to be true. Again, the lines are parallel if you were to graph them. All right, number 6. Your first equation is 6x minus 2y equals negative 4. Your second equation is y equals 3x plus 2. The first thing we're going to do is write them side by side. 6x minus 2y equals negative 4. And then y equals 3x plus 2. My y is solved for here, so I'm going to draw a box around that, and I'm going to come over here and plug that in for y. It's going to give me 6x minus 2, open parentheses. I'm plugging in for y here. 3x plus 2, close parentheses, equals negative 4. Now I'm going to distribute my negative 2 to everything inside the parentheses because that's what the order of operations tells me to do. Negative 2 times 3 gives me negative 6x. Negative 2 times positive 2 gives me negative 4. I'm going to bring down my 6x, bring down my equal sign, and my negative 4 on the other side. So here I have 6x minus 6x, which again is going to cancel. And it's going to leave me with negative 4 equals negative 4. Now this is exactly the opposite of the last problem where we ended up with two numbers that didn't equal each other or a false statement. This is a true statement. So because this is true, what that means is that there are infinitely many solutions. If there are infinitely many points where these two lines cross, then what that means is that if I were to graph them, they would be the exact same line. Because on a graph, every single point along this line is going to be the same as every single point along this line. So they're actually the same line, and that's why there are infinitely many solutions, because no matter where I touch either of these lines, they're going to be intersecting because they're the same. Make sure that you have this down. Again, there is no check here because no matter what you check, it should come out to be true. We will look at a real-world problem tomorrow in class. Make sure that you bring your notes with you when you come. That's the end of your video. Thank you for watching.